So thanks for staying until the last talk. So I'm going to present the scientific committee perspective on the future of CMEMS. And I have prepared the presentation with Neville Smith, who's sitting behind Pierre-Yves. And so based on the feedback that was provided by the scientific committee to Mercator Ocean International during our last meeting back in October. So I will start with a very short introduction about the CMEMS Scientific and Technical Advisory Committee, this is STAC, hereinafter, so with the composition and functions activities. And then I will focus on the core of the presentations on the strategic and scientific advice for the CMEMS of tomorrow. So I will spend most of my time on R&D priorities, but I will conclude with two slides in the end of high-level strategic directions that will hopefully serve also as an introduction for the roundtable that we have after coffee break. So the present STAC is composed by 13 members, including 2 co-chairs. So Neville and I are presently co-chairing. And you have the list in this table of the other members, that some of them are here in the audience. And so Pierre Brasser was the former co-chair in the STAC phase 1, and I took over last year. So the members are selected based on the scientific expertise and background, and also the knowledge and understanding of the Copernicus Marine Service. Very importantly, strict rules are applied to avoid conflicts of interest. So you can have more information on the website. So what are the roles of a STAC? So it's to assist Mercator Ocean International for CMEMS service evolution strategy and R&D activities. So in particular is the definition and regular update of the evolution strategy. So it includes short-term, mid-term, and long-term R&D activities. So on the short-term and part of the mid-term are already conducted by the production centers and so the MFCs and TACs. And so on the mid-terms and long-terms are more part of the service evolution strategy that we have heard during these 2 days, and also other R&D programs, for instance, Horizon 2020. We also, STAC also contributes to the preparation of the CMEMS, so the service evolution calls and the corresponding, so the selection process, the review, and also the monitoring. And very important, one major activity for the second phase of CMEMS is to advise on the long-term evolution of the service. So, and this is the topic of this talk. The 2 reference documents have been presented several times, so I'm not going to spend much time on this. So it's the high-level strategy document and also the other document on R&D priorities. And I'm going to talk now especially on the R&D directions. So this R&D document, priority document, contains a long list of priorities. And there's a long list, it's a widespread, and what we did an exercise during the last meeting was trying to group them a little bit, but still there's 9 topics. And what we did is that they were presented by different experts from the STAC, and with the aim of identifying the gaps and needs for the horizon of 2021. So I'm going to give a brief summary of each of these topics. Obviously, I won't be exhaustive. I don't have time to do that, nor very systematic, because the approach followed by the different members were slightly different. And also, there will be obvious repetitions with things that we have heard during these days, but still, hopefully, will provide some information, useful information. So. Circulation models for the global ocean. This is a topic that was clearly touched by Julien yesterday, and so there are clear links with IMERS. And what was stressed during the presentation that we have, there is a require significant investment in numerics and code optimization due to the increase of resolution in the models. Also, it was stressed the need of developing novel diagnostics to validate the high-resolution models and the increased focus on surface currents and high-frequency processes like tides. For assimilation, again, it was pointed out the need to develop verification methods to assess the reliability of ensembles and probabilistic assimilation systems, identify model bias and forcing errors, and also some new R&D is needed to assimilate the new data streams like ocean currents, ice thickness, ocean color, or new images. Couplet modeling is one of the most significant game changer for the ocean and climate community. There are several sea ice model approaches that are showing promising results that also we have heard this morning, but still the gains in operational context have to be further developed. There has to be need to capitalize also recent and future data sets. Again, encouraging results were presented this morning. The Meso and submesoscale. From an R&D perspective, knowledge and representation of the mesoscale is needed to reduce the alias and systematic errors that are present in some of the products. And this has direct impacts for users who are demanding better estimates of uncertainty and predictability, for instance, in application like for search and rescue or oil spills. Data-driven techniques were also discussed that can provide, that is a new field that also can be explored, especially for the gridded products, combining in situ and satellite observations. Again, it was highlighted the need of high-resolution observations. Then marine coastal systems, there was a long discussion on that topic. This is one of the priority areas. And here I'm just highlighting a few of the conceptual issues that were discussed. We also heard in the previous presentation some of the applications. And so the highlight of the complex of the coupling between atmosphere, ocean, bottom, and land. So it's not just a matter of increasing resolution. There are much other issues. So also we discussed about the need of high resolution wind forcing and fluxes, and the development of flexible interfaces between the regional, so the CMEMS models and also coastal models, touching also the issue of the initial and boundary conditions. For with biogeochemistry, so the models are, it seems that turn out that they are essentially unconstrained by real-time data stream. And in fact, there is no consensus of the right level of complexity, depends on the applications. And the models are not rigorously tested or validated. But there are opportunities in terms of the autonomous platforms that are developing very quickly. And also data-driven modeling and machine learning could be used to exploit the present data that is available. And obviously there are many initiatives evolving the modeling and also data assimilation, and we have also service evolution projects on that topic. Now, observing systems, this is a topic that obviously has, it's a requirement for all the previous topics, so it's like a cross-cutting topic. And the discussion here was about just reminding that the in situ observations currently remain within national responsibilities, so European arrangement is needed to assure the sustainability. And well, so for the satellite data streams, that the ones that are established, sustainability also is a key risk, but some new products were identified, like sea ice, ocean currents, and biogeochemistry, that are the priorities for the remote sensing products. Observing system simulation experiments, also it's something that we have heard also this morning, but it's also a priority that has to continue. And for the C2 also, BGC Argo is one of the priority, but also autonomous vehicles were mentioned. Now, also high-level data products and big data. This is a topic that is included in the R&D document, and that is somehow, it's an evolving topic, so that in the era of big data, this increasing availability of ocean data advocates for the development of some data-driven models and also machine learning. I also mentioned it several times during the previous topics. And there's a wide range of applications from climate to coastal prediction, but also mesoscale and especially biogeochemistry. This is the last one. It's ocean climate product indicators and scenarios. This is, this has also been touched by previous talks. In terms of indicators, well, they are well established, the MOIs, the monitoring ocean indicators that are that were presented by also Karina, I think. And so here, and also we have heard previous talk about the Sustainable Development Goals, and here discussion was to find a smart indicator framework framed basically based on the SDGs. And one outcome of that discussion is that the ocean connects and impacts several SDGs, not only the 14, so we can be more ambitious and try to attempt to reach other ones. Now with this, I finish what was this flash presentation of R&D topics, and I'm just going to the last two slides on high-level strategic directions. So what are the objectives for CMEMS of tomorrow? These are not in priority order, but first one is to lead the development for coastal systems. So we need to networking and develop with new cooperative service elements together with other services, coastal operators, and coastal infrastructures. Develop a new generation of modeling and data assimilation systems at higher resolution with reduced error, so this includes new metrics of validation. And across all EUVs, also especially in biogeochemistry, that they are not all completely covered, and also reaching high latitudes or mean polar areas. So expand the CMEMS catalog. This is something that is already done. Evolve the architecture of CMEMS to meet the new objectives, but always optimizing efficiency and quality. And it might include also the DIAS capability. And finally, so last but not least, to continue advocating for the space and in situ observations that are a strong requirement for the success of CMEMS. So to conclude, so the headline from the Scientific Advisory Committee for the Copernicus Marine Service is that the Copernicus Marine Service is a world-leading marine reference, and for the future, it has to maintain this leadership and foster it. So by continued contributing to increased marine activities and integrated maritime policy at the European level, and also, finally, to put a strong emphasis on strategy. So framing it from top-down approach, so in terms of SDGs, and then bottom-up, in terms of using a user-driven approach. So thank you.